In this video, we will discuss application of derivatives. Importantly, in application of derivatives, three concepts are there. The first one is increasing and decreasing functions. Second is maxima and minima. And third one is derivative as rate of a variable with respect to another variable. First, we will discuss some important problems in increasing and decreasing functions. Now, you see this sum, one function given, we have to find the intervals in which it is strictly increasing or decreasing. The concept is here, if first derivative is greater than 0, the function will be increasing. If first derivative is negative, the function will be decreasing. So we have to find the intervals where the first derivative is increasing and where it is negative. Now we see, what is the given function? F of x equal to 4x cube minus 6x square minus 72x plus 30. The first step is we have to find the derivative. 4 into x cube derivative is 3x square, 3 into 4 12x square minus similarly here 12x minus 72 into x derivative is 1. So 72 into 1 is 72, 30 derivative is 0. This is the first step. Second step, you find the stationary points of this one. Stationary points means the solutions of f dash x equal to 0. So you take f dash x equal to 0 implies this will be 0. So 12 we can take common and you can cancel it equal to 0. Now we will factorize this one. We will use splitting middle term and we can find very simple minus 6 factors. Sum is minus 1. So minus 3 plus 2 we have to take. So x minus 3 into x plus 2 equal to 0. So x equal to 3 or minus 2. These are the stationary points. Stationary points. This is the second step. Now we see. Now our third step. You draw the number line. Number line means here minus infinity or plus infinity. You plot the points, stationary points here. First minus 2 will come. Next 3 will come. Now total number line divided into 3 intervals. Here to here means minus infinity to minus 2, minus 2 to 3, 3 to infinite. In these intervals, our f dash x, where it is positive, where it is negative, we have to find. Now, between minus infinity to one number you take and substitute in f dash x. If it is positive, throughout the interval, it is positive. If it is negative, throughout the intervals, it is negative. Now you tell one number between minus infinity to minus 2. Means before minus 2, what number? One number you tell, that is minus 3. Okay, minus 3 is substitute here. Minus 3 whole square is 9. Minus 3, 9 plus 3, 12. 12 minus 6, 6 positive. So you write here positive. Between minus 2 to 3, one number, 0 you take. 0 is substitute, negative will come. And 3, above 3, one number you take, any number, 4 you take, 16, minus 4, 12, 12 minus 6, 6 positive, positive will come. And one more important thing I will tell that, when the powers, the factors powers are 1 only, always here you will write positive, no problem. Next, alternately change the sign minus, next plus will come. Next you see that, this is our third step. Now fourth step. Fourth step you draw a table, intervals, one column. Next, sign of f dash x. Next, nature of f of x. Observe that this is f dash x, this is f of x. Intervals you write minus infinity to minus 2, minus 2 to 3, 3 to infinite. Open intervals only write always. Next, here positive, here negative, here positive. When f dash x is positive, f is increasing. When f dash x is negative, it is decreasing. Again it is increasing. Now the last step is conclusion only. Where it is increasing, minus infinity to minus 2 and 3 to infinity, the function is increasing. So conclusion you write like this. Can I rub this one? Therefore last step is the conclusion. F of x is strictly increasing in what intervals it is? Minus infinity to minus 2, union 3 to infinity. F of x is strictly decreasing in the interval, only this interval, minus 2 to 3. Okay? Okay, now you see the second sum. Same type of sum only, but the degree of the equation function increased. Fourth degree we have taken. What happens is, see, what is step 1? Step 1 is the derivative you have to take. What is the derivative of this? 3 by 10 into 4x cube minus 4 by 5 into 3x square minus 3 into 2x plus 36 by 5. 11 derivative 0. All of you know the derivatives properly. Now you see that 6 by 5 x cube minus 12 by 5 x square minus 6x plus 36 by 5. What is the second step? First step is finding derivative. Second step is finding stationary points. How we will get stationary points? We have to solve the equation f of f dash x equal to 0. So for finding stationary points, you take f dash x equal to 0. So this will be 0. So throughout the equation you multiply with 5, you will get x cube minus 12x square minus 30x plus 36 equal to 0. You can say LCM. LCM I have taken, that 5 I have sent that side, 0 into 5 is 0. Now with 6 you can divide this one, x cube minus 2x square minus 5x plus 6 equal to 0. How to solve this equation? If it is a quadratic equation, what method we will use? Splitting middle term or formula. But here cubic equation is there. For cubic equation, how to solve the equation? How to solve? We will use factors theorem. You check x equal to 1, you substitute. If it is 0, x minus 1 is a factor. If you put x equal to minus 1, if you get 0, then x plus 1 is a factor. Like that, in trial and error method, we have to check the equation. Here 6 factors only we have to use. No need to use other numbers. 6 factors what? 2 and 3 and 1. So plus 1 plus minus 1 plus 2 minus 2 plus 3 minus 3. These numbers only we have to use. No need to go up to that 3 and these all. First you substitute x equal to 1. What will come? 1 cube minus 2 minus 1 minus 1 minus 5 minus 6 plus 6 equal to 0 came. So x equal to 1 is a root for this one. Knowing x equal to 1 is a root, you divide the polynomial x cube minus 2x square minus 5x plus 6 by x minus 1. So all of you know the division, x square into x cube minus x square, change the sign, minus x square minus 5x minus x square plus x. Here what will come? Minus 6x plus 6 and minus 6 into x minus 6x plus 6, remainder is 0. So actually the equation is now x minus 1 into x square minus x minus 6 equal to 0. This gives x equal to 1. Now this one you have to do splitting middle term. Again you do this. Already we did in previous sum. X minus 3 into x plus 2 equal to 0. So x equal to 3, x equal to minus 2. So what are the stationary points? Minus 2, 1, 3. In order I told. Minus 2, 1, 3. What is the next step? Go for number line. You take the number line. Minus infinity, plus infinity. First you write minus 2. Next you write 1. Next you write 3. Now this number line divided into 4 intervals. What are the intervals? Minus infinity to minus 2. Minus 2 to 1. 1 to 3. 3 to infinity. Now you see, we have to write the sign of this one. Where 0 will come, you tell that? Here 0 will come, no? 0 is substitute in this one. Or f dash x. F dash x means this one, no? Here you put 0. 0, this is 0, 0 plus. So here plus. Now alternately write minus, plus, here minus. Basing on this one, I have done this all. Now you see that. Next step we will write. Table we will write. What columns will be there in table? Intervals, sign of f dash x and nature of f of x. That table we will write. See. Intervals, sign of f dash x, nature of f of x. What is first interval? minus infinity to minus 2, second interval minus 2 to 1, third interval 1 to 3, fourth interval 3 to infinite. Now you see here negative came, here positive, here negative, here positive. Now here decreasing, here increasing, here decreasing, again here increasing. The last step is giving conclusion. F of x is strictly increasing in the interval, increasing here and here, this one and this one. 2 to 1, union 3 to infinity. F of x is strictly decreasing in the interval minus infinity to minus 2 union . See, in our third sum, polynomial not given, some trigonometric expression given. You take f of x equal to sin x minus cos x. Here one interval also given. First step, f dash x. Sin x derivative, cos x. Cos x derivative, minus sin x, but here minus is there. So, plus sin x. What is the second step? Finding stationary points. So, you have to make f dash x 0, then you will get stationary points. Here you see cos x plus sin x equal to 0. This implies tan x equal to minus 1. When tan x equal to minus 1, we have to find the values of x where it will be minus 1. Here all trigonometric functions are positive. Here only sine and cosecant are positive, so tan is negative. Here tan is positive, so minus 1 will not come. Again tan is negative here, so in this we have to see that. Here 135 degrees you take, that is 3 pi by 4. Tan 3 pi by 4 equal to minus 1. How can we know tan 135 is minus 1? First of all, in second quadrant tan is negative, so minus will come. You know that tan pi by 4 is 1. 180 minus pi by 4, you do that. Then you will get this one. Next, again in fourth quadrant, it is negative. So here also possibility is there to get minus 1. What is the value of that one? 360 minus pi by 4, you do that. 2 pi minus pi by 4. How much it is? 2 pi minus pi by 4? 8 minus 1, 7 pi by 4. Tan 7 pi by 4 is also minus 1. Here interval given 0 to 2 pi only, no need to check other values. So the stationary values are 3 pi by 4 and 7 pi by 4. Now again we will take number line as the next step. Number line. But here minus infinity to plus infinity no need to take. Why? Because here limitation is there for x. So 0, here 2 pi, here 3 pi by 4, here 7 pi by 4. See, in our third sum, polynomial not given, some trigonometric expression given. You take f of x equal to sin x minus cos x. Here one interval also given. First step, f dash x. Sin x derivative, cos x. Cos x derivative, minus sin x, but here minus is there. So, plus sin x. What is the second step? Finding stationary points. So, you have to make f dash x 0, then you will get stationary points. Now you see the given interval 0 to 2 pi divided into 1, 2, 3 intervals. 0 to 3 pi by 4, 3 pi by 4 to 7 pi by 4, 7 pi by 4 to 2 pi. Now we will check the sign of f dash x in these intervals. One by one we will take. 0 to 135, you tell one angle, pi by 4. Pi by 4 is substitute in f dash x. Cos pi by 4 plus sin pi by 4. 1 by root 2 plus 1 by root 2. Positive, whatever the value may be, it is positive. Don't alternately put that one. Just one value you take that. Between 135 and this is what 359. 350. Okay, between these two one value you take. Pi you take. Pi, cos pi is minus 1, sin pi is 0, so negative. Now you see the given interval 0 to 2 pi divided into 1, 2, 3 intervals. 0 to 3 pi by 4, 3 pi by 4 to 7 pi by 4, 7 pi by 4 to 2 pi. Now in the last interval, you take 11 pi by 6. 11 pi by 6 cos 11 pi by 6 plus sin 11 pi by 6. 11 pi by 6 you can write 2 pi minus pi by 6. No? So cos 2 pi minus pi by 6 is cos pi by 6 only. Sin 2 pi minus 6 is minus sin 2 pi by minus sin pi by 6. This is root 3 by 2. This is 1 by 2. Root 3 is more than 1. So here it is positive. So positive, negative, positive. Now what is the last step? Conclusion. So f of x equal to sin x minus cos x is strictly increasing in 0 to 3 pi by 4 interval union 7 pi by 4 to 2 pi. Same function is strictly decreasing in only one interval 3 pi by 4 comma 7 pi by 4. Okay.